This is Martin Carlisle with RSA madlibs from pico2018 2018. We ran into some weird puzzles we think may mean something. Can you help me solve one? Connect on port 18148. And there's a link for information on RSA, which is public key cryptography. So I'll go ahead and connect here. 18148. Now the challenge authors accidentally leak the key here. If you turn that sequence of hex digits into ASCII, you're going to get the key. Now, we'll just assume that we don't know that and go on and solve the problem. And it's going to ask us a bunch of questions about RSA. And so in this first question, we get P and Q. We need N. It asks if that's possible. N is equal to P times Q, so that is possible. We can then multiply those together. 93187 times 94603 is this number. 8815769761. Okay, now it asks for Q given P and N. Well, we can do that too, right? So we'll just take N 63154000919 divided by 81203, and that's 12343. All right, now it's asking for P and Q from a really large N, and in RSA, the security of the algorithm is dependent on the fact that for a really large N, we don't know how to factor it into P and Q quickly. So here I'll say no, that's not possible. And now it's going to ask for the totient. Now the Euler's totient is P minus 1 times Q minus 1. And that's an important part of the math that goes into RSA encryption. So 78202 times 79998 equals okay, now it wants the ciphertext. And the way to get the ciphertext is by taking the plain text, raising it to the power 3 mod n. So these things are starting to get a little complicated for what I want to do on my calculator. So I'm going to go ahead and write a Python program that's going to answer all these questions for me. So I'll walk you through that. Let's exit out of that. All right, so here's my program. Now one of the things that's going to come later is this need to compute the modular inverse, because the public key and the private key are modular inverses of each other in the totient of n, p minus 1, q minus 1. So I've copied an algorithm in Python for doing that from Wikibooks. I have the link here. And now we can go through this code. I'm using Pwn Tools, which makes it really convenient for me to interact with this socket at port 18148. I read until I get the prompt for Q. I read until I get the prompt for P. I then read the rest of that as a string and convert it to the integers P and Q. I say, yes, I can solve that problem. I read until I get the prompt for N, and I send P times Q. Now in the second problem, I was supposed to get Q from P and N, so I read for P, read for N, say yes, Q is N divided by P. That third problem was too hard, so I just said no. The fourth problem asks for the totient, which is P minus 1, Q minus 1. So I read for Q, I read for P. Again, you'll see the same 3 lines of code. I read until the prompt. I read the rest of the line and convert it to a number. And then I'm going to send my yes. The totient is P minus 1, Q minus 1. Now the fifth problem asks for the ciphertext from the plain text E and N. And so the way we do that is we do what's called a power mod. We raise the plain text to the power E mod N. Fortunately, that's a built-in primitive in Python. I can just say pow plain text to the E power mod N, and I'll compute that. So The sixth problem is too hard. It's going to ask for decrypting a ciphertext, if I recall correctly, without knowing the key, and that's too hard for us. So we'll just say no, we can't do that one. The seventh problem asks for D if you know P, Q, and E, and D is the modular inverse of E, mod P minus 1, Q minus 1. So there I have the modular inverse of E, P minus 1, Q minus 1. So I, again, read those three values and send the multiplicative inverse. The eighth problem asks for the plain text when given the ciphertext P, E, and N. Now, normally I wouldn't be able to get the ciphertext, but because I have P, I can actually get Q, right? So Q is N divided by P. Then I can get D from the modular inverse, and then I can get the plain text. Now, after I've done all of that, what it tells me is that if I convert that last plain text to hex and then convert it to ASCII, that will be my flag. So I take the plain text, I convert it to hex. This 2: gets rid of the 0x in front. And then Google told me that if I want to convert that hex into an array of characters, I can use this byte array from hex. And then I'm just going to print that out. So I'll go ahead and run this. And here is my key. Do you know the way to RSA? So we'll copy that. I'll get out of here. And there we go.